So we are talking about IBC4EU. I'm sorry that I cannot switch to presentation mode, but I think it's should be big enough for you to see. Well, IBC4EU is a European project. It's funded by the European Commission on the Horizon Europe project, and this project started pretty much 1 year ago. And well, one main aspect of this project is to bring back the manufacturing of PV components back to Europe. And so if we have a look at the global value chain on the various along the value chain, then we see something that it's clear to probably everybody in the audience. I mean, everybody is probably from the PV sector, I suppose. And so we have a clear dominance from China in basically all of the value chains. It's very massive, and of course there's a big dependency on the Asian and Chinese market. So that was one of the main motivation to bring back the manufacturing to Europe. And well, there was the approach in this project was to produce or to develop an interdigitated back contact cell, and to do this basically along the value chain. That's why we introduced or we had a consortium of the whole value chain. And after this presentation, I do what I did not at the very beginning. I will introduce the other speakers. I'm sorry for that confusion at the beginning of this webinar. And
excuse me. We still see slide 1.
Oh no. No?
No, still. First one.
Sorry, I stop and share again. Nothing is moving.
Slide 1.
So
maybe you can try
I'm sorry.
not in a slideshow mode. I mean, just
yeah, I'm not in a
helps.
slideshow mode. I have to Arne. I sent this presentation to everyone this morning. I keep on talking. Maybe you can open it and try to share it. I'm sorry for all the technical issues and problems and now in the beginning.
Yeah, just give me a second to find it.
Even though we had this dry run this morning. Well, so as I already pointed out, that the motivation for the project IBC4EU is very clear: to bring back the production to Europe. How do we do that? By developing this interdigitated back contact cell, and including not only the development of the solar cell, but also the value chain before and after the solar cell into this project. But the cell architecture itself, it's driven by this IBC approach that is promising in terms of higher efficiencies, and therefore, in order to bring down, thank you, Arne.
Tell me which slide you want.
Yeah, that was the one I was talking about. That there's the high dominance of the Chinese in the market, and then we can go on one more. I also need to have a look on the time, not to use too much time. So please go on. Yeah, I mean, so in this project, we will develop and demonstrate in a pilot line this cost competitive and sustainable approach with this cell architecture. And as explained, it's aiming at the whole value chain: ingots, wafer, solar cells, and modules. So please go on. Next one, please.
Okay. Oh, yeah.
Yeah, okay. So, okay. So next one, I think this is. So the project overview. Just to you see this is a European project including many countries from Europe. There are 17 partners plus 4 associated partners. There's a module manufacturer also from Turkey on board. The project will run until for 3 years. So the first year is over. We have already some nice results. So please go on. Yeah, these are the partners on the various steps on the value chain. So we have the on the wafer side, we have Norsun. So that will be the presentation afterwards. On the solar cell side, there we have Valoe. We have also a presentation later on. We have Kalion, Highline, IC Constance, IMEC, and on the supporting level, WIP. We have on the module level Futura Sun, Energira, and Valoe, Finland, ISFH, Becquerel Institute on the supporting end, and we also then have further TNO, CEA, and Protec. And then on the very last step, on the recycling side, we also Lux Chemtech on this sustainability and recycling issues. Next slide, please. Yeah, the approach is, as already pointed out, with the R&D innovations we bring into the game, and the breakthrough for the sustainability, we can have an impact on the manufacturing in Europe. And what's very special is that in this process, in this approach, even though it's a new technology, we can use the existing widely used already existing machinery, which also contributes to the lower cost in the end. So at the end, there will be a pilot line and proving this concept and this cell architecture. Thank you, Anne. Go on. Okay, we can skip that. So this is how the cell looks like. I think I also don't go in detail. I mean, the main feature of such an integrated, interdigitated back contact cell is that you have the metallization-free front, which is avoiding the shading on the upper side, and so by this also contributes to a high efficiency. And this is the main, and both contacts are on the rear end. So this is the main feature of that cell technology. Please go on, Arne. So there are 2 different types, the Polo and the Polyzebra, but I think I'm not going on to explain that. Please go on, Arne. I also have to keep. So I would like to skip that. Actually, also we are already quite late. And we are now here showing the market situation especially on the first step in the value chain, the polysilicon and the wafer side. And actually at this point, I would like to stop my presentation and to hand over to Arne. And I would like to do now what I missed in the very beginning due to the technical problems. Well, I welcome you. My name is Johannes Stiersdorfer from WIP. WIP Renewable Energies based in Munich. We are doing communication dissemination in this project, and we are very happy now to have a few speakers talking about this issue. The next speakers will be from Norsun, that's Arne Dahle and Christian Peter Blom-Stockstad. After that, Julius, they will speak on the wafer side, and then there will Julius and De Navas, he will from Valoe Cells. He will speak on the cell side for the solar cell side, and Nicolo Baccio from Futura Sun. He will explain the module issues in this topic, and then Gaëtan Masson, he will explain us about what are the mechanisms in the European Union, how we try to get back the manufacturing to Europe. And now I see finally Florian. I warmly welcome you.
So yeah, thank you and excuse us again. Sorry really for those technical issues. Thank you, Julius, for actually letting me in and become a presenter. But so just 3 words from my side. Welcome, everyone. Thank you, Johannes, for taking over my part. Well done. And now I'm looking forward to all our speakers, and I will speak again later when we hopefully still have time for a little discussion. So thank you, and please continue.
Anja, Christian, the floor is yours.
Yes. Oh, shit. Can you see my presentation?
Yes, many thanks.
Good. Okay, so I'm Arne from Nordsjön. I'm going to present sort of a little bit of an introduction before Christian takes over and talks more about the supply chain issues. So first of all, just a little bit about what we do. So in our process, we start with silica crucibles that we first fill with polysilicon. And these filled crucibles then go into our pullers, where we have a furnace chamber, and in that furnace chamber we have a hot zone made of graphite, and with that we can melt the polysilicon. Later on we can slowly withdraw our rotating ingot, which is a cylindrical piece, usually around 250-260 kilo. And after pulling, it goes to shaping, where we cut off the top and the tail, and also we square it into square pieces. And after that, it goes to wafering, and finally through a cleaning operation before packaging. So that's sort of briefly what we do. And then in the IBC4EU project, our role is on the ingot and wafer side, obviously. I'm the work package leader for work package 2, which relates to ingot and wafer. And in particular, what we are concentrating on in the project is we are developing hot zone design, because this is very critical for energy consumption and efficiency of our factory. And we're doing this for enabling us to produce M10 wafers. So the next step for us now is to do prototype testing in the factory in the new year. We also have activities on thinner wafers and thinner wire. This is about reducing the kerf loss and making the factory also more efficient. In addition, we have a role in producing ingots and wafers that we deliver to our project partners for further characterization. So that's all from me.
Okay, nice to see everyone. Then I will continue on our part. I hope you can see my screen. So my name is good. Thank you, Arne. So my name is Christian Blomstokstad. I'm a supply chain director in Nordsjön. And actually right now I would like to take us a bit even further upstream than the project scope, because what I would like to share now and the purpose of this last section is to illustrate how we in Nordsjön assess the upstream supply chain complexity, both on the equipment side, so our production equipment, and also for materials, raw materials and consumables. That's on the last, the next and the last slides. We have also included our assessment of the future in Europe. And I have to just make a clear note that our assessment is based on what we know today. So our, let's say, available information is based on market reports, of course, a lot of supplier dialogue continuously, and also press releases and other open sources. And then it's our assessment on top. So I'd just like to point that out. And just to quickly explain the structure of this, what are the variables we have assessed? First of all, it's for each, on this part, each equipment. what is the required kind of quality level / level of customization? So what is the impact on product, wafer quality, and or productivity in our production? And then we have assessed the lead time, and that's a relative assessment between the different types of equipment, and also the share of the cost. And the more red, the more critical for us, the higher complexity. And that's a description of the various equipment with reference to what Arne described now on in our production steps, the various equipment we need. It follows the same process down here. And then the last part of the table is covering our assessment of availability today in the market, in China, in Europe, and then not the least, what we expect of the future. And on purpose, it's not stated exactly when is the future, you might ask. For this assessment, it's our medium-term assessment, meaning 3 to 5 years from now, to give you an idea. And then I would like to point to two specific and describe. I'll not go through all the different equipment types, but I would like to say a few words about two of them. So for the pullers, so the crystal pullers, they have, as Arne mentioned as well, a very high impact on our product quality and also productivity. And it constitutes the largest share of our cost base when we look at the complete equipment park, which means this is a really critical category for us. If you look at the market, there are multiple suppliers in China with a very high capacity, and they are increasing their production capacity as well for assembling these machines. While in Europe, there is, as we evaluate it, very limited, close to zero alternatives, which are both, let's say, productive enough and cost-effective enough for our application. That's the current situation. The good thing is that based on the information we have and the dialogues we have, we see that for the medium term, there are multiple development projects ongoing by multiple suppliers. So we expect that the gap will be decreased and the supply constraint, to call it like that, in Europe will be decreased, but we do not expect it to vanish completely. So we believe it will still be a constraint in the market, and it's fair to note that the different projects in this field are, of course, dependent both on timeline and also the actual technology development. So that's an important note as well. There is a similar situation. Yeah, I'm admitting more people into the meeting. That's good. I guess Johannes, you do the same. There is a quite similar situation on the diamond wire saws. So that's the saws that cut the blocks into wafers. This machinery is also at the moment a very limited supply in Europe. But here as well, we believe this will be improved. So that's a positive thing. There are engineering development done at the moment. And of course, we keep close dialogue with the different actors in this space as well. Then I'm a bit aware of time, so let's now go to the next. It's a similar structure here, looking at our main raw materials and consumables. I think for polysilicon, I'm sure everyone is familiar with the importance of the quality of the polysilicon in our production. It impacts wafer quality and productivity directly, and it constitutes a very high share of our cost base, or OPEX, COGS, basically, cost of goods sold. In China, there is currently an oversupply in this market already, and there are multiple known expansion plans, which means that what is already a market with high capacity will have even more capacity looking into the future. In Europe, there is, as you probably all know, there is a supply in Europe as well, but compared to the global, and I think, Johannes, you shared the slide with the different percentages in the different steps of the complete PV value chain. The supply in Europe today is very limited compared to the total demand globally. We have been able in Norcem to supply Western world polysilicon in our production so far. But still, looking at it from a kind of global perspective, it's limited. On polysilicon, we are in dialogue with multiple companies evaluating and working to set up production in Europe. And that's, of course, very positive. They are in engineering/pilot phase. So there is still, of course, a time again, and also, let's say, technology uncertainty at the moment. But it's very positive that this is already happening, the development of that. We still believe, even with increased capacity, that there will be limited supply in Europe compared to global demand, given that we want to expand as well, and other players as well. And we all want to expand the market, which means the balance, we believe, will still be in that way. Last point I would like to make is regarding hot zone. As Arne mentioned, this is a critical component for us, both in terms of design and how it's, let's say, the quality of the hot zone parts. So it's very important for our process and our result and efficiency. And the main challenge or complexity for us right now in this field is the lead time. It's a very extensive lead time on the graphite parts. Of course, this we need to, and we do plan around that, but that increases the complexity for hot zone. In this space, there are suppliers in Europe already, and we supply majority of these components from Europe already. So it's maybe partly even green up here, but it's still a limited number of suppliers in the market. And we see also limited expansion plans for hot zone, as we know today, which means it will, in our assessment, stay the same. So I think to summarize how we see our upstream supply chain, both now and in the future, we expect that the current constraints and gaps we see in Europe will be reduced, which is very, very positive. And we work together with a lot of suppliers across the different categories we have looked at, and of course support that. And we in Norcem, we believe strongly that collaborating between the different players, different suppliers and customers in the market will be very critical for our common success going forward. Thank you for your attention. I guess, Johannes, you hand it over to the next speaker. I'm not quite sure who it is.
I can do that. So thank you very much, you too. And now let's continue with the cell side. And Julius, the floor is yours.
Okay, thank you. Okay, I hope my slides are visible. Good day to everybody, to the audience. My name is Julius Danofas. I'm a CEO of LS Cells, a solar cell manufacturing company located in Vilnius, Lithuania, and also a partner of IBC4EU project, and where we are leading one of the work packages related to the solar cell processes. So yeah, my quick outline of my presentation. So I will mention a few facts about the company, the technology that we use, and then challenges and opportunities that we have related to the, related in general to being a small-scale European cell producer, and also touching a little bit the supply chain questions, which is the topic of today's webinar. So Valoja basically has two companies, mother company in Finland and the daughter company Valoja Cells in Lithuania. So in Finland, the modules are made, and in Lithuania, the solar cells based on IBC technology. The main maybe market segment of Valoja is not the standard products, but really highly customized solutions for PV. We as a company don't sell commodities like standard cells, standard panels. So for example, if anybody would like to come to us and just get a quote for the solar cell, we probably will not give it, because we are looking differently in how to, let's say, survive in this challenging environment as a European PV producer. Our solution is based on IBC Zebra cell and then Valoja back contact technology, which is developed and adapted to IBC Zebra cell in-house. Main market segments are vehicle integration, buildings, coal transportation, maritime, consumer electronics, aerospace, and agro industries. In addition to the product, we have engineering team who is capable of providing automated lines and systems for the module assembly of using the back contact technology. A few facts about the company which I'm leading, and this is this IBC solar cell manufacturing facility in Vilnius. So it is owned by Valoja OIJ, and we were established in 2019. At the moment we have 20 experienced staff members. Due to our previous history in cell manufacturing as well, our team has quite a good knowledge of not only of IBC technology, but also of the previous generation of solar cells like aluminum BSF, PERC, and MWT, which at that time was based on P-type multicrystalline silicon wafer. Our current production capacity for IBC is only 40 megawatts per year. So this is, of course, nothing comparable to the gigawatt scale Asian companies, but this is where we are at the moment. And so the other two facts were already mentioned. Cell technology, which is also well presented in the project, in this project in general, and that we already probably know. So we have partnered with ISC Consens, and we have implemented their Zebra Pro technology into our production line, which is based on N-type back contact. And maybe the key thing about Zebra is that basically very similar steps like for the PERC or aluminum BSF solar cell is used also for IBC cell production. So we are really not doing any advanced expensive stuff in the manufacturing, and we're able to manufacture a high efficient, good aesthetical solar cell with of course reasonable costs as well. So what are our opportunities as a small-scale European producer? So back contact technology allows us to focus on niche applications, and maybe two things to mention about this niche application. So they might be low in quantity, but they have a high price and also different pricing comparing to the standard pricing in PV industry, which is based on like euros per kilowatt peak, for example. So we are not selling like this our product. And of course, back contact technology is particularly suitable for emerging market segments for PV industry like transport, consumer electronics, Internet of Things, aerospace, buildings. So I think this becomes more and more attractive every year, and this is where we are targeting mainly at the moment. But being a small-scale producer is also good for us in terms of the collaboration. So with the help of European projects, we can have access and direct work with the leading European solar technology institutes. Here below, you can see some examples already of some manufactured products like back contact modules integrated on the trucks on the cooling trailers, and into the light urban vehicles. This is like a piece of vehicle integrated solar module, which is a semi-transparent car roof, and similar products we're making. Challenges. Yeah, so limited local supply chain. I will, in the next slide, I will maybe go a bit more into details about that. Yeah, because we are small and maybe we don't have all materials available in Europe, so availability, costs of raw materials and logistics is, of course, a challenge to us. Small capacity, maybe not so many chances to do price negotiations, maybe to have some kind of long-term contracts with supplier, which could reduce the cost on this part. Not a raw material, but energy. I think it's a very important topic for not only for PV companies, but all manufacturers in Europe and in Lithuania. So high energy prices is a big challenge these days. I will also go into one slide into a bit more details about that. And maybe another challenge for us is that because we are targeting this niche market, so we have a relatively long time between prototyping and mass production stages in these niche sectors. So of course, expansion, ramp up of production is not a quick process. Yeah, a few facts about the supply chain. So I did some quick calculations of our, let's say, expenditure on materials for the last year. And just a very quick summary would be that 68% of money that we spend on consumables goes to non-European countries, which is mainly Asia, not only China, but Asia. That, no secret, it includes key materials like wafers and silver paste, and some other supplies that are needed for metallization process, for example. So unfortunately, we cannot buy them in Europe at the moment, and this is, of course, then brings us with some challenges like lead times, costs, and maybe less impact to the supplier in terms of negotiations as well. Yeah, in Lithuania, we can buy about 27% based on value of raw materials, which is gases, for example, gases, chemicals, and similar items, and some of the chemicals also are delivered from other European countries. So yeah, we don't say that there is nothing in Europe. There is for sure. I think like we saw in the previous presentation by Norson, but anyway, key materials are at the moment not produced in our region. Electricity. I'm using a publicly available source in the slide, so I cannot guarantee that every business is really paying the exact price like shown in this graph, but in the case of Lithuania, so manufacturing companies are very close to these numbers, what is paid for the 1 kilowatt-hour of energy. And comparing to United States, China, these are few times larger. So definitely this is a big cost element especially for the small scale production. And we are, of course, being a small company is not maybe so easy to change that or influence that, but we are, I mean, what we can do, let's say, as a company, so of course, and we hope to implement it during next year, is to produce our own energy in the remote solar power plant. And we expect at least to do something about this until maybe some regulations, some prices in the country changes, and this challenge could be lower, we hope. Yeah, so what else can be done about challenges and how to avoid them? So of course, R&D projects for a company like us helps a lot. And one of the ways is the reduction of expensive silver paste and replacing by other materials. So this is what we are working together with partners on IBC4EU projects, and looking forward to achieve goals like having hybrid metallization by using partially copper paste in the contact structure of IBC solar cell, and also implement innovative metallization designs and processes which could help to even reduce the consumption even further. I think these new materials could have potential to open maybe some local manufacturing of supplies, hopefully in our continent. And based on these R&D results, I think the other high scale producers can really also pay attention to that and probably benefit from that on the gigawatt scale production, more than let's say small scale producer like us. The other thing where we are looking a lot is end of life PV, and I don't want to advertise the other two projects a lot, but just want to mention that I think this direction can help partially solve maybe issues which we have in the supply chain by recovery and the reuse of raw materials from end of life PV, modules, solar cells, broken wafers, and then in these projects we're exploring reuse of silicon, silver, glass, and also encapsulated material. This might be a bit in the long term, I would say, because a lot of questions are not still answered, like quality of recovery materials, price of the recovery process. So, but we are working on these topics, and hopefully they will be applied in the commercial activities as well. Maybe, well, I don't feel very strong in not talking about, let's say, political situation, but of course, everybody in this meeting, I believe, and in our company, we're following what is going on, and I mean, the European Commission level, and then also at the member state level in local governments. I think they have major impact by making the right and quick decisions in order to solve issues with the supply chain and support for the PV producers. So maybe three things just to say from my side, from our company side, that we are supporting and that we hope that could materialize soon. So I think we really need more support oriented towards manufacturing, not only for installations. This maybe is very visible, I would say, in our country, in Lithuania. So I mean, there is a very good incentives for the end users of renewable energy, support to install PV system on your house roof or for the businesses as well. But nobody now really supports, and nobody really establishes mechanisms for the local manufacturing. So we are really missing that at the moment. On the other hand, it seems that some initiatives are really coming and taking attention. Recently, it was the idea of the European Solar Manufacturing Package was published by ESMC, so I don't maybe spend much time talking about what is written in it, but I think it's really, really interesting. As an example, to have a specific quote of for local manufacturers in terms of the market share, which might be some kind of very specific and very concrete and understandable solution. And maybe the last point which I want to mention, so which could of course help for European producers, for the maybe companies working the supply chain as well. So horizontal type of projects, they are really great, but to make them even more, to make the impact even bigger and stronger for the companies, and that these projects could help even more, I think we need to make them shorter. And especially we need quicker application and evaluation processes, because at the moment when we apply to these projects, we are, I would say, we write application, we submit it, and that's easy 1 year. Then we have few months until evaluation happens and the project starts, and then we have 3-4 years for duration. So of course it's not bad for the low TRL development, but if we want some kind of quick solution for the manufacturing level, we need to be shorter. Yeah. So thank you. These were my key things that I wanted to mention in this webinar. Yeah, looking forward to questions in case there is any.
Thank you very much, Julius. And I would suggest to directly continue, Nikolai. From the perspective now of Nikolai, from a perspective of a module producer. So please.
Yeah.
Go ahead.
Thank you. Okay, I hope that you can see my screen and you can listen me. So, okay, good morning, everybody. I'm Nicola Baggio from Futurasan. I have, first of all, to thank also the previous speaker because they have already introduced, let's say, most of the hot topics related with the criticalities that we have nowadays in the supply chain of PV module. And for this reason, I'd like to spend a few words, especially for the audience, that maybe we have some students or some other people not really aware of the history of the PV, to explain, by my point of view, of course, a little bit of history and of the industry in the PV sector in Europe, and how we can probably avoid to make the same mistake again in the near future. Just to going back in 2003, so 20 years ago, as also mentioned from the previous speaker from Valois, in Europe, through several European directives, the market receives a big stimulus to start the installation in Germany, in Italy, in Spain, Romania, UK, and other countries with a feed-in tariff, basically a mechanism. And this system works, and also nowadays it is working quite well in several places. And that time, there were industries in the PV sector in Europe. Also here in Italy, in the northeast of Italy, in the radius of 30 kilometers from my desk here, we got probably that time 20 different industries working in this module manufacturing, solar cell, but not only, also the other components like encapsulant, junction boxes, glass, frame, and so on. And let me say that starting from that time, we have started to walk our green mile to came at the end to kill, let me say, the European industry, and also through some bad policies. One example is the MIP, and just to clarify, it is not an import duty. So nowadays there is a big discussion around also between different European association in the solar sector related with the import duty. It is an instrument, but this instrument was never applied really. So MIP, it is a completely different mechanism, and this type of mechanism really didn't help that time the industries to survive due to import duties also on solar cell, on glasses, and so on. We finally recognized that at European level, European Union level, that energy is a strategic sector due to the increased electricity price, also already presented in the previous slides. But in Europe in general, starting from 2021, due to the let's say nuclear crisis during the summer in France, and then with the Russia invasion of Ukraine, we got this massive increase of electricity cost. We have to remember that in any case, we are still purchasing a lot of fossil fuels from not democratic regimes around the world. Maybe nowadays they are a little bit more friendly than Russia, but okay, Russia was a friend few years ago. So it is important to put into a more, let's say, big context the discussion that we are having now. So we need to decarbonize everything, everywhere, all at once. There's no discussion about this. So we need to work with China today, but hopefully to have a supply chain in Europe tomorrow. In order to rebuild again, let's say, a supply chain in Europe. Also, as previously mentioned, we have to see many. We have to work on many different aspects for all the components. By our point of view, as module manufacturer, we are investing now here in Italy to build a new factory, a 1 gigawatt plant here in Cittadella in Veneto region. And so we are looking for solar cell, and we are aware that behind the solar cell there are other materials like polysilicon, ingot, wafer. We have silver and other gases and so on. But we need also all the other components, and it must be clear that today we only have few possibilities as European supplier for encapsulant, ribbons, backsheet, and glass. And in general, the volume is not enough to cover the European demand. So, of course, it is much more capital intensive an investment in the upper part of the supply chain. But also we have to recreate a network of companies in Europe producing other, let's say, more simple material, we can say, like junction boxes or frame with good quality and reasonable price that it is not possible to find today. As Futurasan, we are trying to give our contribution, of course, through the IBC4EU project. Especially developing a stringer machine. Here you can see just a drawing, but I think it is quite curious as layout in order to produce IBC modules in a very fast, efficient, and possibly cheap, let's say, way. So we don't have to make our fight against China only on the let's say policy side, but also trying to again to be a step forward by the technological point of view. The module, as module manufacturer, we believe, probably, I don't know if there's a misconception, but we believe to be the locomotive of the photovoltaic industry train, and we don't see the other manufacturers in Europe as competitors in this moment. I hope to have and then to see competitors and to be in competition with other European manufacturers in 10 years, or I don't know, even less, but to be honest, 10 years from now, because we need a critical mass to have then several local solar cell supplier to add and to sustain the additional investment on the upper part of the supply chain. We need much more investment also on solar glass. Currently, we have just 1 or 2 potential supplier in Europe. As I told before, we don't have, honestly, supplier for the junction boxes and for aluminum. This is also related with the duties that there are already in place for aluminum goods. And as the colleague of Valoé already mentioned, we need stable rules for the industry, very clear. Nowadays, we have very clear mechanism not only in China but also in the United States with the IRA. So we hope to have a quick decision from the European Union in order to promote the investment in Europe. We are doing our part. Okay, we are doing our, let me say, small 1 gigawatt plant, because it is small compared to Chinese standard. But then we need to have a stable policy for 10 years or for a decent period of time. Even if nowadays we are producing our module in China, we are considering the import duties as a possible, let's say, instrument that we have, or we have to be very clear in Europe to use certain limit, for instance, for the module LCA or sustainability in general, and to reject eventually modules or materials in general that not respect the value that we agreed together. But we need to move faster, because it is not just an industrial problem, it is a climate problem. And we see every second day that we have a massive, let's say, weather event, and it is not really possible to wait and see in this situation. So I really hope to recreate the European supply chain. It will take some years, but we are here to do our small part. Thank you very much.
Excellent. Thank you, Nicolas, and for sharing your take on the matter. And now I will hand over to Gaëtan from Becquerel Institute, who will give us some further insight from my, let's say, meta perspective, hopefully. And yeah, floor is yours. Maybe you could share the other screen, then we would see the not the presenters, but presentation.
The right one. I never know how to do that. Wait a second. Do you see it now?
Yeah, now we see the PowerPoint mode, the standard mode.
Let me reshare my screen in a second.
Yes, that usually helps.
So thanks for your patience. We already are at 1 hour as scheduled, but I hope that everybody will stay online to listen to Gaëtan. I'm sorry for the trouble in the beginning, so we are a bit late, but please stay online if you can and listen to Gaëtan's presentation.
What do you see now?
The same as before, unfortunately. And what I can say now already is to promise next time will be better. There will be a follow-up webinar to be announced soon. Yeah, perfect. Thank you. And so go ahead and yeah, I will continue my thoughts afterwards.
I'll try to be fast. Not going to present Becquerel Institute in detail. Yeah, but you don't see my slides changing. That's the same problem as. Wait a second. I need to find something else because that's not. You don't see my slides changing, right?
You're right.
No, it's. We have an unlucky star on the sky today.
Yeah, if things don't work, then
I'll just send it to me and I'll put it up.
Arne is the IT coordinator of the group.
Yeah, that's not a good day for.
That's Murphy's law, right? If things go wrong, everything go wrong, or something like that. But yeah, let's see.
Okay, should be fine now.
Yes. So please go ahead.
I will not say too much about Becquerel Institute, except that we are a research and consulting company specialized in PV, established in Belgium, France, and Spain. Just open an office there. I will go very fast through the context, then explain a little bit what is being done at EU level with some examples. I don't have to remind that market demand is there, that we might have more than 100 gigawatt of market demand in Europe by 2030, with roughly 50-50 between distributed and centralized applications. Of course, distributed applications are more easily targeted in the case of European production, knowing that cost questions are less important. If we're looking a little bit at projects which have been announced, and there are many more than that slide it's just willing to show that there is some willingness to reindustrialize, and things are changing fast. So I will not spend too much time on that, but I would like to focus a minute on the issues that we have and which are the cause for many delays in manufacturing projects that we have seen in 2023. The first one is the very sharp decrease that we have seen in PV module prices, but also cells, wafers and polysilicon, which is frightening many investors, because when we finished that figure, we were below $0.19 per watt peak, which is a little bit the high range of Chinese production costs, but price went down significantly further. I took a print screen from PV Insight this morning, which is confirmed by what we see in the market, is that the lowest prices that we see for the time being for commercial PV applications in Europe, it's between 12 and 13, 14 US dollar cents per watt peak. I can let you conclude that it's very difficult to convince any kind of investor that we will be able to sell at 25 or 30 cents if the Chinese are selling at that price. Now, the question is, what does that mean? Is it possible to produce at that price? We, of course, know that it's not the case. And that the problem that we have for the time being, it's coming mostly from a huge overcapacity of Chinese production. Just put a very small figure about what was produced in 2022. So with a market around 240 gigawatt, we had total production of 365 gigawatt in China, mostly crystalline silicon. And want to spend more about that, which is even more frightening. It's the production in the first 2 quarters of the year 2023, and this is production in China itself. Numbers are from the Chinese PV Industry Association. 600,000 tons of polysilicon have been produced. Wafer production was 253 gigawatts, cell production 224, and module production 204. The discrepancy between these 3 levels are coming from the fact that Chinese wafers and Chinese cells are exported to Chinese companies manufacturing outside of China. Which is even more problematic is that in general Q3 and Q4 are even higher in terms of production than the 2 first quarters. So we are definitively in a situation of massive overproduction in China, and production capacities are even higher than that, with probably the equivalent of polysilicon for 1,000 gigawatt of annual production, between 600 and 900 from wafer to modules. And that's a significant issue that has to be solved one way or another if we want to be sure that the industry could be developed elsewhere. And this risk is perceived by private investors. I just copied this morning the stock value of Meyer Burger. Meyer Burger is the only European company which is listed on stock markets. And after some growth in the beginning of the year, in the expectation of the Net Zero Industry Act that I will explain in a minute, we saw from, I would say, mid-July, a little bit after the SNEC fair in China, a significant drop in Meyer Burger's share. And the explanation is given by investors is quite clear. What's happening is that many investors are extremely frightened by overcapacities in China, and we do not think that a fair market or free market could lead to reindustrialization in Europe. So how to solve that? And if we're looking a little bit at all the problems that companies wanted to develop PV manufacturing in Europe are facing, there are roughly 5 categories. I will not go in depth, otherwise we are there until 2 p.m. But one is definitively length and permitting. Permitting, even if the Commission has voted to reduce it to maximum 18 months, is significantly too long in many cases. Land is complex to find for a 5 or even a 10 gigawatt vertically integrated factory in Europe. There are not so many places where land is suitable with regard to water and energy employment. We have a second category of issue, which is definitely the question of supply and raw materials and equipment. I will not talk about that because this has been mentioned in Norsen's presentation. We have an issue on skills and training. PV requires massive labor in the thousands of qualified people. It's not so easy to find, and I will say a word about financing. I will not go into detail, but there are plenty of policies which have been tried in the last years all over the world to support local manufacturing, not only in Europe, and some of them have been quite successful. I would say that, in my opinion, the most successful ones are local content requirements in countries where it's doable, which can be applied in numerous different ways. But there are other things like tax credit for factories, grants for land or infrastructure, low-cost financing, lower energy prices, something which has been mentioned also in Julie's presentation, labor charge reduction, and so on and so on. And indirect one, import tariff and trade duties, bans, import bans on non-sustainable products. We have discussions in Europe with regard to banning products made by slave labor, of course, CO2 footprints, and many, many other things. I will not go through everything. The question is, how can we set up that in Europe? And we have many things which are ongoing in Europe for the time being, on the downstream side and on the upstream side. I will not spend too much time on the downstream side, but focusing more on upstream, so the industry. The Green Deal Industrial Plan of the Commission, which has been presented in the first quarter of the year, is probably the most advanced set of regulations. And normally it should be voted in the European Parliament. So the update should be voted in the European Parliament in the coming weeks, with, in addition to the Critical Raw Material Act, which has been already presented, the Net Zero Industry Act that states that the European Commission would like to have 40% of local production by 2030, and additional things on training and skills building. But one of the most important things which has been added by the European Parliament is the willingness to limit to 50% the imports coming from countries which haven't signed the global procurement agreement of the WTO. So basically limit to 50% imports from China. That's something which is not implemented yet, which is discussed for the time being in the European Parliament, which might be voted soon. Which is already in place is the temporary crisis and transition framework, which allows state aid. Now that's a real revolution for people following a little bit EU policies. Since the treaty establishing the European Union in 1992, it's the first time that state aid is allowed for private investment in a specific industry. This is a temporary framework, but it allows member states, so countries, to invest directly in the PV industry. In terms of financing, there are things which are already in place. There is a lot of money in the Recovery and Resilience Plan, which in some countries have or should be targeted towards PV manufacturing, and the Innovation Fund has financed until now projects from Meyer Burger, Norsen Treason. REC got money, but decided not to use it. There are other elements which are quite important. The European Solar PV Industry Alliance, I will say a word about that in a minute. The other one is the carbon border adjustment mechanisms, which is also complicated in my opinion, because it really depends how CO2 calculation can be implemented. And the most complicated of all is probably trade defense. I would bet that we'll get trade barriers safeguard measures or something else. France just asked for it publicly yesterday in order to protect the industry, but you might know that most PV developers in Europe, especially Solar Power Europe, are totally opposed to any kind of trade barriers and any kind of limits to import Chinese PV products in Europe. And that's a little bit what I would like to mention in one of the following slides, is that the PV industry in Europe is not united for that. This slide, and I will not go in detail through that, shows what's the current temporary crisis and transition framework, which is already in place and which allows countries to invest directly public money in the PV industry. And there's no need to say more than that. It depends on the region, the size of the company, and it even go up to 100%. In a very specific case, which would be a bit too difficult to explain here. It's a very significant and important step forward on the financial side. The European Solar PV Industry Alliance is an organization which has been created with all existing organizations, Solar Power Europe, the European Solar Manufacturing Council, but also InnoEnergy, in order to make proposals to the European Commission on how to incentivize the European renaissance of the industry. And I can tell you that it was horribly complicated because Solar Power Europe involved downstream players, not industrial players, in the discussion. And so the compromise that was found was not too bad, but extremely difficult, because we are still in a situation where a large part of the industry in Europe doesn't want to make any compromise on price and cost, and would like to be able to source extremely cheap PV panels from China, whatever the situation. And so the European Solar PV Industry Alliance finally came with a certain number of proposals to the Commission, which in my opinion are quite good, but it was an horribly complex discussion with many non-industrial players, unfortunately, involved in the discussion. I will not say anything about that because I've already mentioned them. Two important things: the Critical Raw Material Act, which should help the European Union to continue developing local resources, and especially provision of polysilicon, for instance, but glass might be involved at some point, is something that will be extremely important to redevelop some parts of the value chain in Europe. And I've already mentioned the Innovation Fund as a way to finance the industry. And I will finish by that. I know it's late. There is market demand, and there is a willingness to pay for European-made products in some market segments and some countries. It depends where you go, but it depends on the price difference. If the price difference is 100%, there is basically a limited willingness to pay for European-made products. If it's 15 to 20%, it might be the case. So in any case, the price gap must be reduced, and the price gap must be reduced first by fighting against what's happening for the time being, this current abusive overcapacity in the industry on the Chinese side, which will have to be solved either by China or by Europe, by either partially closing the market or putting in place measures to be sure that 40% of the market can be served by European companies. The EU framework is really progressing. The resilience concept, so the idea that we should have a local industry, not to be dependent on countries that do not share completely our values, is now something accepted. It doesn't mean that it's yet implemented. But on the negative side, there will be no additional EU financing simply because the European budget is totally empty. And that many member states, including Germany and the Netherlands, for instance, are campaigning against any increase of the EU budget. So we will not have any additional financing in addition to the Innovation Fund and the Recovery and Resilience Fund at European level. And it's not the EU that should be blamed, it's member states. And member states will also have to take their part of the burden by financing CapEx side, because state aid is now allowed. Many in the industry are asking for OPEX costs to be covered, and there are some countries where, for instance, electricity price might be reduced for the industry. But there is also the need to continue redeveloping other parts of the value chain, and this is something that is ongoing partially at European level, but which will have to be done also at national level. I'm thinking about glass, for instance. CO2 content regulations, it's nice, it's important, but I don't think that it will be useful. And I think our Chinese friends are doing as good at company level as we can do. Slave labor regulations are coming, but I don't think either that it will be a major step forward. And for the rest, we can be extremely creative through regulations to develop products which are different from the Chinese ones and go for specific regulations to be sure that they will have a market access. And that's all for this time, folks. I hope I wasn't too long for him.
No, not longer than the others. So thank you very much, and yeah, for this great overview. And I think to summarize, we can say it's not the big hit, right? It's not the one that will liberate everything and unleash inherent growth. But yeah, I think we can still be a little bit optimistic for the future, since the market is so big. The outlook is also so positive, and I think more and more states are realizing that it also has a strategic and importance to being able to produce solar photovoltaic components within their immediate reach and not only in one country. So unfortunately, we don't have time for further discussion between the speakers and the audience. We will use all those learnings, including how to use Teams, and hopefully have a much better organized webinar next time. Again, I guess during the lunch break. So I'm looking forward to seeing you all again, and promising already now that it will be better organized, slightly different in terms of focus. So stay tuned. And with that, I would like to thank the speakers again. Johannes, for jumping in for me. Thank you very much. Highly appreciate it. And yeah, thank you for joining, everyone. And we'll see you soon, and have a good rest of the afternoon.